All right, this video is going to cover the law of cosines. So the law of cosines works for these two types of triangles, side, 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 and side, angle, side. What the law of cosines is this craziness. So it's c squared equals a squared plus b squared minus 2ab cosine c. B squared equals a squared plus c squared minus 2ac cosine b. And a squared equals b squared plus c squared minus 2bc cosine a. Okay, so whenever you have triangles where it's not a right triangle and you're given only three sides or two sides and the angle in between those two sides, we're going to use the law of cosines. All right, so let's put the law of cosines in action. If we're given a triangle like this, when I draw it, we've got A, B, C, angle A is 30, little b is 3, little c is 4. So you can see we have a side, angle, side triangle. We've got two sides and the angle in between them, which is great. So luckily with law of cosines, it doesn't work on any SAS triangles. So you never have to worry about the ambiguous case where you have more than one solution. So for me, whenever I'm solving for triangles, I always write out everything just to make sure I don't forget anything. So I know that little b is 3, little c is 4, and angle A is 30 degrees. So when I set this up, let's first solve for little a. So we'll use the formula. Side a squared equals b squared plus c squared minus 2 times b times c times the cosine of angle A. Throw that into a calculator and you'll end up getting that a squared equals 4.22, and then when I square root, I get that a equals 2.05. All right, so now you can solve for either angle B or angle C, whichever one you want to do. I'm just going to decide to do angle C. I don't know why. I've just decided that. You could totally solve for angle B first and get the same answer. So if I solve for angle C, I'm going to use the C formula. So that says little side c squared equals a squared plus b squared minus 2 times a times b times the cosine of angle C. So I get 16 equals 13.22 minus 12.3 cosine of C. So all I did is I squared this and added it to 9, which is what 3 squared is, and that's what gave me this number. And then I multiplied 2 times 2.05 times 3 to get that 12.3 number. So my whole goal is to isolate that cosine C to get it by itself so I can do the inverse function. So the first thing I'm going to do is subtract 13.22 from both sides. When I do that, I end up getting 2.78 equals negative 12.3 cosine of C. Divide both sides by negative 12.3. And we get negative 0.226 equals cosine of angle C. And then we'll do cosine inverse of both sides. So that ends up giving us angle C is about 103.1 degrees. And I could go through and do the law of cosines to find angle B, or I could just remember that when you add all the angles together, that adds up to 180 degrees. So we've got 30 plus angle B plus 103.1 degrees equals 180 degrees, which leaves me with angle B equaling 46.9 degrees. There we go. All right, so let's look at the situation where I'm going to have three sides of a triangle given. So we've got angle A, angle B, angle C that I'm solving for, and they've told me the three sides. So that's 8, 5, and 4. Okay, so first things first, I'm just going to solve for angle A. So using the law of cosines, side A squared equals B squared plus c squared minus 2 times b times c times the cosine of angle A. So that gives me 64 equals 41 minus 40 times the cosine of angle A. Subtract the 41 from both sides. Sorry, that was my alarm. Subtract the 41 from both sides, and I end up getting 23 equals negative 40 cosine of angle A. Divide both sides by negative 40. So I get the cosine of angle A equals negative 23 over 40. Take the cosine inverse of both sides. And I end up getting A equals 125.1 degrees. And now I can go through and I'll do the same thing to solve for angle B. So we've got side B squared equals A squared plus C squared minus 2 times A times C times the cosine of angle B. So I'm going to let you guys go through, solve that all how you normally would, how we did over for A, and you end up getting that B is about 30.8 degrees. Okay, and then again to solve for C, I know that when I add up all the angles, I get 180 degrees. So 125.1 degrees plus 30.8 degrees plus C. So C ends up being 24.1 degrees. All right, now we're going to actually, so now you know how to use the law of sines and the law of cosines. So now let's put them into action and actually use them to solve application problems. These are actually used in the real world quite regularly. So we have a ship that's going from St. Thomas to St. Croix, and it's 40 miles away from each other. It maintained a constant speed of 23 miles per hour, but it encountered heavy crosswinds and strong currents, and they found that after 1 hour, the yacht was off course by 41 degrees. So it was off course, so instead of going in this direction, it was off course by 41 degrees. If it was going 23 miles an hour, after 1 hour, it's gone 23 miles off course. So we're trying to figure out how far is the yacht from St. Croix. There's my yacht. So I'm looking for solving for this right here. All right, so we have, let's see, we've got a side, angle, side, triangle. So when I have that, that's a law of cosines. So let's figure that out. So I know this, we'll call that x. So x squared is going to equal 23 squared plus 40 squared minus 2 times 23 times 40 times the cosine of 41 degrees. So we end up getting that x is about 27.2 miles away. So this is 27.2 miles. How much time has been added to their trip because of this? Well, now they've gone 23 miles in the wrong direction, and they're going to have to go 27.2 miles in this direction. So they have to go 23 plus 27.2. They need to go 50.2 miles. The trip was supposed to be 40 miles. So how many miles did that add? Well, they now have to go 50.2 miles. The trip was originally supposed to be 40 miles, so they've added 10.2 miles to their trip. If they're going at a speed of 23 miles per hour, that would be, you can figure that out, so 10.2 miles. We want to figure out the time, so that means the hour needs to be on the top and the miles on the bottom. So 1 hour, they go 23 miles. That way I'm just left with the hour for time. So that ends up adding a total of 10.2 over 23 hours, which is about 0.44 hours. Now, if you were going to put that in terms of minutes, okay, we've got 0.44 hours. Changing it to minutes, we know there's 60 minutes in 1 hour. That way those cancel, and I'm just left with minutes as my unit. So that's 26.6 minutes that it added to the trip.